Let's do line structure for 3-methyl octane. So it's 2, 3, 4, 5, 6, 7, 8, 1, 2, and then a 3. And then it's C9H20. And for 2-methyl octane. And it's also C9H20. And then 2, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3. And this is C10H22. So the relationship that these two things have is that they're isomers. We're going to talk about isomers today. Name this one. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. All right, so it's 8. So I'll just go this way. So there's my octane. And then on my octane, I got this thing, and this thing, and this thing. Which one of these is closest to the end? This side over here, I'm going to call this carbon number 1 because the first side chain is closest to that end. You okay with that? If I call this number 1, then the first side chain is on carbon number 4. So, oh wait, that's not a side chain. Oh yeah, my bad. So this right here is an F, and then I got a prop and a prop. All right, so I'm going to do 3 ethyl 4,5 dipropyl octane. Are we okay with that? I know this di thing is kind of silly because I just told you there was one on number 4 and number 5, so of course there are 2 of them, but the redundancy is in there. Can't do anything about it. Waste product for fusion? It's just helium, right? I mean, does that sound bad? The waste product for fission reaction is a bunch of radioactive stuff that's radioactive for thousands and thousands of years, and it's very dangerous. And this stuff, its byproduct is helium. I mean, literally, you would capture this and sell it to Fred Meyer and like florist places to make balloons. Like, there is nothing, it's just helium, nothing else to it. So it'd be great if we could do that, but why are we not doing that?
Yeah.
Why not? Gives off too much energy. All right, let's look this guy up so I can grab it. Oops, I didn't want to do that. Actually, I don't know how to do that. Can I undo? Huh. Looks like a nice beach, right? I mean, if the nuclear power plant wasn't right there, it looks like a nice beach, right? Yeah, I've walked right past this thing, and it is a really nice beach, except that nuclear power plant's there. So, what was the question? Is this a problem?
Yeah.
I would say this is a problem. Why is this a problem? Just like Japan. We've got an area that's earthquake prone. plus it's right next to the ocean. Just like a completely stupid idea, in my opinion. I don't know if they've taken any extra precautions because they knew it was an earthquake zone, but it just doesn't seem like a very good design. Why didn't they just move it in 500 yards or a half a mile? I don't know. Whatever. Not an awesome idea. Okay, so let's talk about this one. I'm reading the paper. I come to this article. I find the article. I read the article. Article has got a bunch of flaws in it, and then I look at this graphic, and I like get very upset. Why am I upset?
The first picture, it looks like the entire atom explodes.
If the entire atom exploded, then what would the byproduct, the waste product, be for fission? If it completely exploded in this image, what's left behind? What are those things what are those little balls that are leaving? No?
That's protons and neutrons.
Protons and neutrons. So hydrogen and neutrons. There'd be no waste product at all. It'd just be hydrogen. Like, nobody cares about that. Nothing would be radioactive. So that's a big... No. Would be great, but no, that doesn't happen. You get two large chunks, usually rubidium and cesium, which are radioactive for a very long time, 3 neutrons, and not that much energy. So a large release in energy, well, okay, it is large compared to some things, but it's not. When I go down to this one, smaller release of energy? No, backwards. We don't do this one because the release is so large. And then my other problem is these two are good, but we don't make this. We make regular old helium, which is the byproduct. So I'm upset. I'm reading this thinking, why in the hell would the Oregonian do this? I sent them a message saying that the AP report was wrong. So then I called the University of California, Los Angeles. I called UCLA and asked for the physics department. And the lady said, we don't have a physics department. I was like, okay. And she's like, our physics classes are taught out of our science department, but we don't have a physics department. So I'm like, can I talk to somebody in the physics department about an article that I found on the AP Wire? And so she sent me to the department chair. And I said, hi, yeah, I was trying to get a hold of the physics department. And he's like, yeah, we don't have a physics department. I'm like, yeah, I get that now. I'm just, so I found this article online and I directed him. And so I'm just talking to him on the phone while he's searching. And he's like, I'm like, just read the bottom of the graphic. He's like, we don't have a physics department. I'm like, and what's wrong with it? And this graphic is terrible. I'm like, yeah, and you've been sourced on it. Okay. So he and I both tried to track the art of the woman down, but the Associated Press wouldn't give us any information about it. And then we both told the AP that this is wrong. So you should reconsider accepting any articles. Do you know what the AP is, the Associated Press? So you can apply to the Associated Press as a journalist, and you could be working for a newspaper or not working for a newspaper. You can just be a freelance journalist. And if you write an article and submit it to the AP, they'll either accept it or not accept it. And then it goes out on this wire service. So before it was literally, they would just telegraph it to different newspaper outlets, and the newspaper outlet would take it or not take it. And if they took it and published it, then they paid AP some money, and then the AP kicked the writer some money. So what this means is there was a hole in the paper of the Oregonian, and they needed to fill a spot. And so somebody went on the Associated Press and typed in a little, we need 400 words and it needs to be this size. And then a bunch of articles came back and they're like, oh, let's take this one. And then they just plugged it in there. Didn't bother to read it. Didn't bother to ask the science editor if this made any sense. Just picked an article. So this is the kind of stuff that drives me crazy about newspapers and whatnot. if this would have been posted online, there would have been like 10,000 comments and it would have been taken down immediately. Like, that's the nice thing about people are like, Wiki's not a real source. So the newspaper is a source, but it's wrong all the time. And if you do something like this on Wiki, it would immediately get abolished. Other people would come in and say, no, that's not how it works. All right.